Welcome to Across the Globe. Today we will learn about Introduction to Numpy. Numpy is a critical Python package for scientific computing. It facilitates handling of vast, multi-dimensional arrays and matrices. Additionally, it furnishes a variety of mathematical functions to manipulate these arrays efficiently. For instance, in data science, Numpy is commonly used for tasks like matrix operations, statistical analysis, and numerical computations, making it an indispensable tool for researchers and professionals working in fields that involve heavy number crunching. Numpy is a Python library primarily used for numerical operations. The main data structure in Numpy is the end array, which serves as a multidimensional array. Arrays can be fashioned by utilizing the np.array function, where a list or tuple is submitted as input. For instance, you can initialize an array in Numpy like so. Python import numpy as npr np.array 1 2 3 4 5 print r. In this example, a numpy array named r is created with elements 1 2 3 4 5 using the np.array function and subsequently printed. This fundamental operation demonstrates the process of constructing a basic numpy array in Python. Numpy enables element-wise array operations like addition, subtraction, multiplication, and division using standard arithmetic operators. For instance, given arrays R1 equals 1, 2, 3 and R2 equals 4, 5, 6, you can execute R1 plus R2 to obtain a new array with the summation of corresponding elements. This simplifies working with arrays in Python for data processing and scientific computations. Numpy offers capabilities for modifying array shapes through functions like reshape and resize. The reshape method in Numpy can be utilized to alter the shape of an array. For instance, if you have a 2D array like AR equals np.array 1, 2, 3, 4, 5, 6, you can reshape it to a 3-2 array using ar.reshape32. This function transforms the array dimensions while retaining the data elements. This feature can be particularly useful in scenarios like image processing, where reshaping arrays is crucial for various operations. Just like a builder uses various tools like hammers, nails, and saws to construct a building, a programmer uses libraries like Numpy to efficiently work with large arrays and datasets in Python. Numpy is like a Swiss Army knife for handling numerical and mathematical operations in Python, providing a wide range of functions and tools for data manipulation. Using Numpy is like having a powerful set of Lego pieces that can be easily snapped together to create complex structures and arrays in a program. Just as a chef uses a set of high-quality knives to chop, slice, and dice ingredients quickly and efficiently, a data scientist uses Numpy to perform fast array operations and calculations on large datasets. Hey, Code Conquerors, ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. The code provided above serves as an analogy-based explanation of Numpy in Python, comparing its functionalities to tools used by professionals in various fields like builders, chefs, and data scientists. Firstly, the code begins by importing the Numpy library, setting the stage for utilizing its functionalities for numerical operations. Numpy serves as a versatile Swiss Army knife for handling large arrays and datasets efficiently, akin to how a builder requires different materials like bricks and concrete for construction projects. The example showcases the usage of Numpy functions, such as np.add to efficiently add arrays together, drawing a parallel to how a builder might use a hammer for driving nails. Similarly, the code demonstrates calculating the mean of an array using np.mean, likened to a chef using quality knives for precise ingredient preparation. Numpy's capabilities extend beyond basic operations to complex mathematical tasks like matrix multiplication, reshaping arrays, and more. This versatility is likened to a set of Lego pieces that can be assembled to create intricate structures, reflecting how Numpy empowers data scientists to handle large datasets and perform advanced numerical calculations with ease. In the realm of data science, Numpy emerges as an indispensable tool for array operations and numerical computations, providing speed and efficiency in handling vast amounts of data. Just as a chef relies on sharp knives for culinary tasks, Numpy serves as a reliable asset for data analysts. In essence, Numpy stands out as a fundamental library in Python, enabling programmers and data scientists to navigate numerical data and arrays proficiently. The analogy-based code demonstrates how Numpy's functionality mirrors specialized tools used in different professions, emphasizing its significance in numerical data manipulation. In the industrial sector, Numpy finds applications in fields like engineering and manufacturing for data analysis and processing. For instance, in structural engineering, engineers can use Numpy to analyze large datasets related to stress distribution, material properties, and structural integrity of buildings or bridges. By leveraging Numpy's array manipulation capabilities, these professionals can efficiently perform complex calculations and simulations to ensure the safety and reliability of their designs. Moreover, in the realm of finance and investment, Numpy serves as a valuable tool for quantitative analysts and traders. They utilize Numpy to handle massive financial datasets, perform statistical analysis, and develop algorithmic trading strategies. With Numpy's array functions and numerical operations, these professionals can gain insights into market trends, risk assessment, and portfolio optimization, enabling informed decision-making in the dynamic world of finance. Overall, Numpy's versatility and performance make it a fundamental component in various industrial applications, empowering professionals across different sectors to tackle complex data challenges and drive innovation. Keep learning, stay curious, and I'll catch you in the next video.